Hello everybody, welcome to today's math class. Today we have this wonderful exponential equation before us here. This is an India Math Olympiad challenge. How do we solve this exponential equation? First of all, x to the power of x equal to minus 1. What is the possible value of x that will satisfy this equation? If you're new here, this is Math Prowess. If you've not subscribed, subscribe. That is the only way you get notified whenever we drop an amazing video like the one you're about to watch right now. So let's take our solution to this. Friction. All right. Now, if you take a look at this equation, the right hand side of the equation will give us some challenges here. But how do we handle this? So we're going to consider this equation for a set of some complex numbers for this left hand side, so the right hand side of this equation. So what does that imply? So let's rewrite the original equation. Here we can say let our z be a set of complex number. That will be for our 1. So rewriting the original equation, we're going to have our x all to the power of x now be equal to z. So what we do here now to get our x here, we want to log both sides of the equation. So let's take log to base 10 on both sides of the equation because of this exponent here. So this will give us here log of our x to the power of x to base 10. Okay, so this is equal to log our z to base 10. Now, according to the law of logarithm, we say that if you have, well, let's say if you have log our m to the power of k, this is an exponent. Then move this power back here. So this will give us here k times log our m. Okay. So remember this log. So we want to move this exponent, which is this x, to the side of the equation. So doing that, this will give us x times log our x is 10. This is equal to log our z. Easy, right? At this point, we want to do some simple substitution here. So what we do here now, I want to say let. Okay, so for me, I want to say let's put u this time. So let's say let u be equal to our log x. It is log x. So if u is equal to log x, we can make x the subject of the formula by introducing our e into this system. So we're going to write e to this power here and e to this power in order to eliminate this log here, right? So introducing e, this will give us here e to the power of u, equally do same to this side, e to the power of log x here. Since we are bringing in a here now, we have to change the base number here because the base number can no longer be 10 again. So we are assuming at this point for this expression here, we are applying log base e. I hope we are not confused here. So if we're having log base e, what does that imply? It means this will go with this. So we're going to have our x now be equal to e all to the power of u. Let's hold this equation. Okay, this is a very nice equation we're going to make use of. We probably make use of this very one also too. This very one will make use of this very one. So let's keep this equation. Let's give this equation star. Let's give this equation star star. Yeah. Okay, with what we have here now, let's go back to our original equation or where we made our substitution. Look at this equation here now. Let's come back to this equation. We want to put the value of our x, which is this, and the value of our u into this equation here now. So substituting these will give us here, look at our original equation. So what is our x? Our x is e to the power of u. So we're going to have here e to the power of u times. Then what is our log x? Our log x we solve for, or we substitute for, we have it to be u. So this times u equal to log our z here. I believe no confusion here, right? Now we can rewrite this expression here on the left hand side to give us our u times our e to the power of u. This is equal to log z. Now, if you check this expression we have here now, something comes to mind, and that is what we call the product log or the Lambda Wn function. We know that. Now, what does that function say, or that product log? What does it say? It says that if you have, let's put it down on this other side, if you have your e, okay, let's take a star, the times your e always to the power of a star, then you decide to take the Lambert and W function of the system. This will give us a star. What is it? So if we have that, we have a similar expression there. Yeah. So we have u times e all to the power of u. So we want to take the Lambert and W function of both sides of the equation, and doing that is very easy. So this will give us here our W and bracket our u dot our e all to the power of u close bracket. So long we are doing that to the left hand side of the equation, we must do that same thing to the right hand side of the equation. So this will also give us the Wn function of our bracket log bracket our z close bracket close bracket. Are we learning something here? Yeah. So what we observe from the left hand side, we're going to have our u, everything here will end up giving us u here will now be equal to the Wn to our log bracket z close bracket close bracket. Now we don't have u at first in our equation. What we have is x. Look at the equation here now. What we have is just x here. So there is a place where we said let u be something. Look at it here. Yeah. We said let u be equal to log x. So according to equation star, we can bring back our x into the system. So from here, we now say recall. Yeah, so let's say recall. We said that our u should be equal to log our x here. So in place of u, let's put in log x, right? So this now implies that our log x will now be equal to the Wn function of our log bracket z bracket square. We want to eliminate our log this e here because we're looking for x here. So we just bring e into the system again. So this will now give us here, we're going to have our e or to the power of log our x. This is equal to, we'll equally bring that to this side, e to the power of the Lambert Wn function of our log z here close bracket close bracket. So from here we see what happened is this and this will leave the system. So we now have our x will now be equal to our e all to the power of w and bracket our log bracket z close bracket close bracket. So this is the value of our x. But recall we don't have z in the beginning. What we have here is minus 1 here. So from Euler identity, we know that our e all to the power of your I pi plus 1 is equal to 0. So if we move this to this side, we're going to have our e to the power of our I pi is equal to minus 1. So we can bring this into our system here to take the place of minus 1 as we substitute for our z back again to the system, right? Now, but for some set of integer for k, for any integer k, we can have this system to be something nice, right? So we can have this to be our I pi bracket 1 plus 2k is equal to minus 1. Yeah, let's go back to our equation here and where we're going to substitute for our minus 1 here. So if we look at this here now, we can get our log z from this system here because we know that our Z is equal to our minus 1 here, right? So anyway, we see minus 1, we want to replace it with our expression we have here now. So we can now come back to this expression here and we write our answer for our x. So we're going to have here, this now implies our x will now be equal to our e, right? E, or to the power of the Lambert NW function there, bracket our, put this bold well, so we have here log bracket our I pi bracket our 1 plus 2k close bracket. Are we confused here? No, we are not confused here. All right, so let's close this very well. So we can rearrange this very well to give us here our e out to the power of wn, then close bracket, our log bracket, our 1. Sorry, let's start with 2 this time. So 2k, then plus 1 close bracket, I pi. Yeah. So let's close our bracket. All right, so this is the value of our x in the system. So how do we get the numerical value for our x here? Here, we must choose our n and k wisely to ensure a valid solution for our x here. E.g., okay, so e.g., for our n, if we're taking our n to be 1, what will be the value of our k we're going to consider? We're going to consider k to be equal to 0. So with this, let's substitute this into our equation and see what this gives us in turn. So this is going to give us here our x will now be equal to our e all to the power of our w there 1 into our log there. We said our k is 0. So the whole of this will give us what? 1. So into our bracket I pi. Yeah. So if we plug this into our Wolfram calculator, we're going to have our x to be minus 1. So this gives us minus 1. All right. So this brings us to the end of this math challenge. If you learned something from this math challenge, give the video a thumbs up. And again, if you're not clear with any of the steps we analyzed here, then leave it in the comment section so that we can actually throw a little explanation to it. Here, this is my prowess. If you learned something from this video, do not forget to share this video with your family and friends, those who need this knowledge of mathematics. Thanks for watching Math Prowess all the time. More videos to be released. Keep watching Math Prowess. Bye.